Okay, so some common risk indicators include the factors that we're going to be looking at include general health of the economy. How well is the economy doing? A little bit scary today and a little bit scary for the foreseeable future is in terms of the economy because of all the new issues coming on with this virus. The industry of operation, what industry are you in? Today, if you're in the medical industry, I think things are looking okay for you. You're going to be very busy over the next few months, if not years. The current volume of sales, probably less relevant today because things are going to change dramatically over the next few months. And then your makeup of fixed and variable costs, and really that's going to be related to the operating leverage, but we're going to get to that later. And then ultimately we're going to be looking at the margin of safety and computing the margin of safety and then the operating leverage. So these are general concepts. We have specific numbers we can look at for the margin of safety and how that's computed. So let's look at the margin of safety. There's going to be 2 slides associated with this. We're talking about the excess of actual over expected sales over break-even sales. So we're looking for that dollar amount that's going to be above the sales amount we need to at least break even. Whatever we sell above that, that's going to be considered the margin of safety. So drop in sales, the company can absorb without incurring a loss. So if our anticipated sales are $100,000 and we know that our break-even point is at $75,000, then the difference between the 100 expected and the break-even point of 75, that difference is $25,000. That's going to be considered our margin of safety. So the higher margin of safety, we have less risk. That should be pretty obvious, but we certainly would like a situation where we can have a pretty significant drop in sales and still be able to survive. So let's assume K generally sells 950 posters a month. So our margin of safety in units, our margin of safety in units is equal to the expected or actual sales in units. So in this case we're going to use our expected because we're going to just go with the 950, right? And then we're going to subtract from that the break-even sales in units. So we know that this is 950, and we're going to subtract from that the break-even sales in units. Now, what we're going to use for this is the 500, and if you recall, way back in the day when we first started doing this analysis, when we just had a single, without a multi-type situation, we went back, it was somewhere around right here. Break even the income statement approach or even the contribution margin. The units that we'd come up with when we were first doing this was 500 posters. Okay, disregard the multi-user, just go way back to the beginning where we were just using it just a single poster, right? So if we use the 500, the difference is 450. So now we know that the margin of safety in units is 450, and we get that by taking the 950 and subtracting the 500. So if we want to convert that to margin of safety in dollars, we're simply going to take the 450 units and multiply it by the sales price per unit of $35. That's what it was when we first started. When we came up with that 500 break-even units, that's the sales price we used. So 450 units times the 35 units, that's going to give us a total of 15,750. So that is going to be our break-even. Our margin of safety, our margin of safety. So that's going to be our margin of safety in dollars. So if we want to compute the margin of safety, a margin of safety as a percentage, we'll simply take the units, which means we'll take the margin of safety in units, which we previously computed to be 450, and then we'll divide that by the expected or actual sales in units. In this case, it would be 450 divided by 950. These are number of units. So 450 posters divided by 950 posters, and that's going to give us 450 divided by 950, which gives us a percentage of 47.4 rounded to the nearest tenth. So if we do this in dollars, we're going to really do the same computation. So we'll take our margin of safety in dollars, and we're going to divide that by the expected or actual sales in dollars. Same as this, except instead of units, we're focusing on dollars. And if you recall, the dollar amounts we had that we previously computed were 15,750. That was our margin of safety that we'd come up with. Our expected was 33,250. So 15,750 was our margin in safety. Our expected sales in dollars, 33,250. 15,750 divided by 33,250 brings us to 47.4%. So we're going to get the same percentage between the units and dollars. So we'll move on to the next slide, and the operating leverage and operating leverage factor. There's two slides associated with this. The first part is relative amount of fixed and variable costs that make up total costs. So you have your total costs. Some of it is variable, some of it is fixed. How much of your total cost is made up of variable, and how much of it is made of fixed costs? And that can be pretty important as we're trying to weigh risk. So the operating leverage factor would be how responsive a company's operating income is to changes in volume. At a given sales, the contribution margin divided by operating income. So at a given sales, the question becomes is what does our contribution margin look like relative to operating income? And the reason why we're interested in this is because the greater the operating leverage factor, the greater impact a change in sales volume has on operating income. So let's take a look. Indicates the operating leverage and operating leverage factor indicates the percentage change in operating income that will occur from a 1% change in volume. The lowest possible value would be 1. So let's take a specific example to see if this makes any sense to us. Let's assume K sells 950 posters per month, which I think we've already done that before, but let's assume it in this example. So in this case, the contribution margin is 950 posters times $14. And that's going to give us a total of 13,000. total of $13,300. We're going to subtract from that fixed expenses. And so our operating income is $6,300. So we'll compute the operating leverage factor. We'll take the $13,300 and we'll divide that by the $6,300. So what that means is $13,300 divided by $6,300. So our operating leverage factor is 2.11. So the way we can interpret this is that if K's volume changes by 1%, her operating income will change by 2.11%. And that may be up or down. So if sales go up by 1%, then her operating income is going to increase by 2.11%. If sales go down, her operating income is going to be down 2.11%. So when you have a lot of fixed costs, you're essentially taking on a lot of risk. With a lot of risk means that there's going to be some dramatic changes in income relative to changes in volumes. A company who has high fixed costs relative to variable costs is considered to be highly leveraged. So highly leveraged means you're taking on more risk. Now, taking on more risk isn't necessarily a bad thing. What you know is that if you have more fixed costs and volumes go up, then you're going to make a lot more money, because what you pay is what you pay. The increase in sales is going to have a big or dramatic impact on the amount of money you're going to make. By the same token, if sales volumes go down, then the fixed costs still have to be made, so you're taking on a lot more risk. So it's a risk-reward kind of deal. So staying on with leverage, operating leverage, the characteristics of high operating leverage firms. High operating leverage companies have the following. They have higher fixed costs and lower variable costs. And they have higher contribution margin ratios. For high operating leverage companies, changes in volume significantly affect operating income, so they face the following: higher risk, higher potential for reward. So the example here are examples pretty interesting. The examples that we have here include, examples are golf courses, which are shut down now, hotels, rental car agencies, theme parks. Interesting, most of these are going to be struggling through all this. Theme parks, airlines, cruise lines, etc. So it's kind of interesting that, you know, with this virus issue that we have going on right now, that the ones that are going to be struggling the most are going to be, or the ones that are highly leveraged, like golf courses, hotels, rental agencies, theme parks, airline, cruises. Those are the ones that are going to be in the deepest trouble right now, because golf courses are shutting down, obviously. Hotels those are going significantly down because people are traveling less, and everything else that we're listing there are going to have significant decreases in volumes and sales. So therefore, they're at a pretty high risk right now. It's going to be very difficult for them to kind of survive this economic issue that we're dealing with now. So the characteristics of low operating leverage firms. So these are low operating leverage companies have the following. They have higher variable costs and lower fixed costs. They have lower contribution margin ratios. So therefore, for low operating leverage companies, changes in volumes do not have as significant an effect on operating income, so they face the following: lower risk, lower potential for reward. So the example here giving is the examples: merchandising companies, and fast food restaurants. So then finance people are often facing the question is the cost structure. And so what we're talking about is the indifference point. The indifference point is the point at which a company is indifferent between two options because they result in the same total cost. Okay, so let's assume that K has two leasing options, option 1 and option 2. Under option 1, the variable cost is going to be 10% of sales, and so per unit that would be 10% of $35 per unit. So therefore they're going to be having to pay $3.50 per poster. In addition to that, they'll have a fixed cost, like a base amount that at a minimum, so to speak, they're going to have to pay $300. Now, under option 2, there's no variable cost at all. It's just a flat rate of $1,000. So we're going to compare those two, and at some point in time, we'll look at option 1. Where does option 1 equal option 2? How many units do we have to sell where it's essentially the same thing? So we'll take a formula of quantity times the variable cost per unit plus the fixed cost. That's under option 1. And how does that compare to the option number 2? The option number 2 is going to be just $1,000. There's variable cost plus fixed cost on both sides, but under option 2 it's just simply $1,000. Under option 1 it's $300 plus the fixed cost. So what do we know? We know, I'm going to go ahead and get rid of the QTY and just put a Q, quantity times VC per unit, plus, and we know that the fixed costs are $300. So that's what we're looking at, is how can we solve for this so that we know that they're really the same? And if we're talking about units, then we'll use kind of like the same kind of formula analysis that when we were doing the approach to coming up with the break-even point, we're going to go ahead and solve for Q. If we go ahead and plug in the numbers we do know, we don't know Q, so that's the unknown variable, but we do know that the variable cost per unit is $3.50, and plus $300, we know that to be equal to $1,000, or we want it to be equal to $1,000 to get to our indifferent point. Okay, so what are we going to do? We can then isolate or try to isolate the Q. So we're going to go Q times $3.50. And what we'll do is we'll subtract $300 from both sides. So that's going to be 0, and this is going to be equal to $700. And now to isolate the Q, we'll divide both sides by 350. So then Q will be equal to $700 divided by $3.50. 700 divided by 3.5. We're isolating the Q, we're solving for a Q. That comes up with 200 units. At this point in time, we know that if we think we can sell 200 units, then we're indifferent. For the most part, we can do either option 1 or option 2 and just feel good about it. There's really no difference in our case. But the question becomes is, what do you think? Are you going to sell more than 200 units, or are you going to sell less than 200 units? If you firmly believe that you're going to be selling more than 200 units, then you're going to want to go with option 2. And the reason being is because option 2 is fixed. $1,000 does not go up relative to the quantity. So you're going to actually make more money by going with option 2. If you think it's going to be 200, you're indifferent. It doesn't matter. It's going to be about the same cost. However, if you're conservative and you're thinking, well, I don't even know for sure if I'll hit the 200 mark, then you might be inclined to go with option 1 because there's less risk. There's variable costs associated with it. There's only a $300 fixed cost associated with it. So if sales or volumes don't go as expected, you should still be okay under option 1. You'll have a better chance of surviving if your volumes are lower. Under option 2, if you guess that you're going to sell more but end up selling less, then you're going to still have that fixed cost. So more risk on the right side, option 2, because it's all fixed costs, less risk on option 1. However, more reward on option 2, because if you blow away the situation where you actually sell 5, 6, 7, 800, 900 posters, option 2 has fixed cost, and that's all you have to pay. While option 1, you're going to have to pay a whole bunch of variable costs, $3.50 per unit, so you're going to make less money under option 1. Okay, that's the end of chapter 7. I hope you have a good understanding of chapter 7, and I hope it's useful for you for your studies and for your homework.